What if the greatest equation ever written was actually hiding a secret that even its own author refused to say out loud? Einstein gave us E equals mc squared, and every textbook on the planet taught it as the final answer, the end of the road, the trophy on the shelf. But here is the shocking part nobody talks about. Einstein himself admitted in private letters that the equation was incomplete. Not wrong, incomplete. There is a staggering difference between those two words, and most people walk right past it. Mass converts to energy, yes. But what decides when that conversion happens? What triggers it? The equation tells you the exchange rate between two currencies. It does not tell you who opens the bank. The missing piece was not mathematics. It was something far more disturbing. It was the nature of reality at the smallest scale. A world where cause and effect themselves start to dissolve. And Einstein could not bring himself to accept what lived there. What if "I don't know" were actually the most powerful scientific statement a human being could make? More powerful than any theorem, more honest than any textbook, more dangerous than any bomb. Every classroom on Earth teaches science as a collection of answers, dates, formulas, laws, named after dead men in paintings. But the real engine of science, the thing that actually moves human understanding forward, is not the answer. It is the precise location of the uncertainty. The moment you can draw an exact circle around what you do not know, you have done something extraordinary. Einstein saw this. He saw that quantum mechanics was not just a new theory, it was an admission that nature, at its foundation, does not behave the way human intuition expects. And that admission terrified an entire generation of physicists who had built their careers on the assumption that the universe was, at heart, predictable. It is not. What if two particles could be connected across opposite ends of the universe, and what happened to one would instantly affect the other, faster than light, with no signal, no wire, no explanation? Einstein called this spooky action at a distance. He said it sarcastically because he believed it was proof that quantum mechanics was broken. He thought no serious theory of reality could allow such a thing. And then Bell's theorem arrived. Then the experiments. And the universe looked the human race dead in the eye and said, "Yes, actually, that is exactly how I work." The spookiness is real. The connection is real. And the implications are so catastrophic to our normal understanding of space, time, and locality that most physicists today quietly use the math, collect the results, and do not ask what it means. Because the moment you start asking what it means, you end up somewhere deeply uncomfortable. What if the act of looking at something physically changes what that thing does? Not as a metaphor, not as philosophy, but as a hard experimental fact that has been confirmed thousands of times in laboratories. This is the measurement problem, and it is arguably the most scandalous unsolved problem in all of science. A particle travels as a wave of probability, existing in multiple places, multiple states, all at once, until you measure it. The moment you look, it collapses into one definite reality. But why? What is special about measurement? What is special about a conscious observer? Does the universe need to be watched to decide what it is? Einstein refused to believe it. He spent the last 30 years of his life trying to prove that the randomness was an illusion, that there were hidden variables running underneath, making the outcome predetermined. Every single experiment since has said there are no hidden variables. What if time is not a river flowing forward, but a landscape, already fully formed, where past and future exist simultaneously? And the feeling of now, moving forward, is nothing more than a feature of human perception. Einstein's relativity demolished the idea of absolute time in 1905. He showed that time moves slower near heavy objects, slower at high speeds, and that two events that appear simultaneous to one observer are not simultaneous to another. This is not science fiction. GPS satellites have to correct for this effect every single day, or your phone's map would be wrong by kilometers. But here is where it gets genuinely unsettling. If time is relative, if it bends and stretches, if your clock and my clock run at different speeds, then the present moment is not a universal fact. It is a local experience. And what that implies about free will, about memory, about the nature of death itself, is a question most scientists refuse to sit with. What if the universe is not made of matter, not made of energy, but made fundamentally of information? And physical reality is something that emerges from it, the way a video game emerges from code. This was not a fringe idea. John Wheeler, one of the most respected physicists of the 20th century, spent his final years arguing for exactly this. It from bit. Every particle, every field, every event in the universe, at its deepest level, derives its existence from answers to yes or no questions, from binary choices, from information. Einstein saw a gap in quantum theory and could never fill it. What he missed, what almost everyone missed, was that the gap was not in the math. The gap was in the assumption that there is a physical world sitting out there, solid and real, waiting to be described. The deeper you look, the more the solid world dissolves, and what remains is not matter. Let me tell you something that will bother you for the rest of your life, if you are paying attention. Einstein was wrong. Not about the math. The math was magnificent. I mean, he was wrong about what the math meant. And the difference between those two things, between the calculation and the meaning, is precisely the gap where the most important truth in modern science is hiding. And almost nobody is talking about it. Now, most people think physics is about equations. They think if you understand the formula, you understand the thing. That is exactly backwards. The formula is a map. The territory is something else entirely. And Einstein drew the most beautiful map in history. And then, and this is the part that should shock you, he looked at what the map was pointing toward, and he refused to go there. Quantum mechanics arrived in the early 20th century like an uninvited guest who breaks all your furniture and turns out to be right about everything. It said the universe is not deterministic. It said particles do not have definite positions until you look at them. It said nature, at its root, runs on probability. Not because we lack information, but because probability is genuinely, fundamentally, all there is. And Einstein said, no, there must be something underneath. There must be hidden variables. There must be a deeper layer of reality that is clean and causal and sensible. He believed in a universe that did not play dice. He was wrong. The experiments proved it. The universe plays dice, enthusiastically, constantly, at every scale smaller than you can see. But here is the thing nobody tells you. Einstein being wrong on this particular point does not make quantum mechanics comfortable. It makes it worse. Because what quantum mechanics is actually telling us, if you read it honestly, if you follow it to its logical conclusion without blinking, is that reality as a concept is far stranger than any religion ever imagined and far more disturbing than any nightmare. Consider what happens when you measure a particle. Before measurement, it exists as a superposition, a smear of possibilities. It is not here or there. It is a wave of probability amplitudes, a ghost of potential, fully described by mathematics that has no corresponding picture in your mind. The moment you interact with it, the moment a detector clicks, the moment an atom in your eye responds, the wave collapses. One outcome crystallizes out of the fog, the rest vanish. Now ask yourself, where did the other possibilities go, and why did this one show up? There is no answer. Not "we don't know yet." No, the theory does not have an answer. The most successful, most precisely verified theory in the history of human science gives you a perfect formula for predicting the probability of what you will see, and then goes completely silent on the question of why that one and not another. The curtain drops exactly there. Einstein hated this, and honestly, who can blame him? There is something aesthetically offensive about a fundamental theory that says, here is how to calculate your odds, and refuses to say anything further. It feels incomplete. It is incomplete. The question is whether the incompleteness is a flaw, something future physics will fix, or whether it is a feature of reality itself. The evidence at the moment points toward feature, because then we discovered entanglement. Two particles interact, separate, travel to opposite ends of a room, opposite ends of a city, opposite ends of the galaxy. And when you measure one, the other instantly responds, regardless of distance. Einstein called this spooky action at a distance, and argued it proved the theory was broken. Particles, he said, cannot signal each other faster than light. The universe has a speed limit. He was right about the speed limit. He was wrong about the conclusion. What we learned, what the experiments of the last 50 years have confirmed beyond any reasonable doubt, is that the two particles are not signaling each other. They were never separate. The entanglement is not a connection between two things. It is evidence that, at the quantum level, the idea of two separate things is itself an approximation. A convenience. A story we tell ourselves because our brains evolved to track lions on a savanna, not to navigate Hilbert spaces. And this is the hidden gap Einstein saw but could not cross. He saw that quantum mechanics was incompatible with his own theory of relativity. He spent 30 years trying to build a unified theory that would make them both comfortable, both sensible, both local, meaning that causes only affect nearby effects, that nothing reaches across space without traveling through it. He never finished. Nobody has. The gap is still there. Quantum mechanics and general relativity, the two most successful theories in physics, are mathematically inconsistent with each other. They cannot both be completely correct, and the place where they break down is exactly at the boundary where the very small meets the very massive, at the center of black holes, at the moment of the Big Bang, precisely where the most interesting questions live. What lives in that gap? We do not know. That is not a comfortable sentence. That is the most important sentence in science right now. Because here is what I want you to understand, really understand, not just nod at and move on. The fact that we do not know does not mean we are ignorant. It means we are precisely located in our ignorance. We know exactly what we know exactly where it breaks, and we know exactly what kind of theory would need to exist to fix it. That is not failure, that is the frontier. That is the most exciting place a human mind can stand. Einstein saw the frontier. He drew the map right up to the edge. He just could not make himself step off into the uncertainty beyond it. And the lesson, the one that should change how you think about knowledge, about certainty, about the difference between knowing the name of something and actually understanding it, is this. The greatest discoveries do not come from people who are comfortable with the answers. They come from people who are deeply, productively, relentlessly uncomfortable with the questions. The universe is stranger than we think. It is stranger than we can think. And the gap Einstein left behind, that crack between quantum and relativistic reality, is not a problem waiting to be solved by a clever enough equation. It is an invitation. It is the universe telling us, in the only language it has, that we have not yet learned to ask the right question. The truth was never hiding. We just kept looking at the map instead of the territory. This speech is about one of the deepest intellectual tensions in the history of human thought. The collision between what we can calculate and what we can understand. Einstein gave us the tools to predict with extraordinary precision. Quantum mechanics gave us the most accurate theory ever constructed. And yet, between these two towering achievements, there is a crack, a gap that whispers that our map of reality is not reality itself. The quantum truth Einstein saw and struggled with is not a solved puzzle. It is an open wound in the body of physics, beautiful, disturbing, and still bleeding. The courage science demands is not the courage to find answers. It is the courage to stand inside uncertainty and not flinch. That is the gap, and you are standing right at its edge. What if I told you that the smartest human being who ever put a pen to paper, a man whose brain rewired how civilization understands space, time, and energy, spent the last 30 years of his life losing an argument with the universe? What if the equation on every physics classroom wall is not the finish line, but a signpost pointing towards something so strange, so fundamentally unsettling, that even its greatest champion refused to follow it all the way? Einstein saw the crack. He saw the place where all his beautiful mathematics stopped making sense, where particles communicate instantly across impossible distances, where the act of looking at something physically changes what it does, where reality itself seems to dissolve into probability and fog. He saw it, and he looked away. Today, we are going to walk straight into the place he refused to go, because the most important truth in modern science is not in the textbooks. It is in the gap. And nobody has told you what is hiding there.